Everyone, I am Dr. M. Monikam, Assistant Professor at Department of Physics, Dr. SNS College of Arts and Science, Coimbatore. So today, in this video, we will discuss about flip-flop as a RAM cell memory. So the building block of digital memory. So we are going to discuss. So actually, this is a lecture series video. Continuously, we are talking about in this series about the semiconductor memories. So today a flip-flop as a RAM cell. So this is what we are going to discuss today. So first of all, we'll start with the what is flip-flop basics. So flip-flop means a bistable circuit with two stable states capable of storing one bit of informations. So that is either or zeros and one binary bits we are using. So for the operation of the flip-flop. So flip-flop means on off condition, 1 or 0. So this is what we are going to use the mechanism in this flip-flop working functions. So this fundamental property makes it the perfect building block for digital memory. So how this flip-flop is using for the digital memory. So we will going to discuss in detail. So first one is it's a memory element. That is how the flip-flop is using as a memory element here. So it is act as a basic memory element in sequential logic circuits, so that maintaining data integrity across clock cycles. So this is the memory element we are using in the semiconductor memories in the RAM cell. So the next one, edge triggered operations, how it is operated. So changes state only on clock edges, so ensuring perfectly synchronized data storage across the entire system. So this is the edge triggered operation, so we are using in the flip flops. So historical foundation, so it is invented in the 1918 as the Eccles Jordan trigger. So it became fundamental to all the modern digital electronics. We are using these flip flops. So this is the basics of flip flops. Then we are going to discuss about how the flip flops is using in the memory cell, RAM memory cells. So flip-flops in RAM. So the heart of the SRAM. SRAM means static RAM. So which is the advanced one when compared to the DRAM. So we have discussed in our previous video. So SRAM cell structure. So this is the static RAM uses the flip-flops with 4 to 6 transistors per cell to store bits reliably. So providing robust data retention. So this is the advantages of SRAM. The next one, data persistence. So each flip-flop holds the data indefinitely until deliberately overwritten, enabling lightning fast random access operations we are using. So by using the flip-flops, we can use this kind of operations. So no refresh is required. So it is a very fast one. So we no need of refresh the system or computer. So it is automatically refreshing and giving the good output delivery. So the fast action. So while using the computers. So practical examples, that is a 4-bit RAM system can be constructed using 4D four different D flip-flops. So these are the different types of flip-flops is that we are using D flip-flop types here. So D flip-flops paired with the address decoders for the process control. So this is a practical examples for the flip-flops which is used in the RAM cell memory. So that is in the type of static RAM. This is the practical RAM implementation using the D flip-flops, how it is implemented. So why we are using flip-flops in the memories means, so D flip-flops are chosen for their stable and direct data storage capability, and the output reliably follows the input on each clock edge, so ensuring data integrity. So this is the by using the D flip-flops, the data will not lost, or it will not vanish. So that's what we are using this D flip-flops in the RAM cell memories. So here three mechanisms is there. That is the address decoders, synchronous design, and the educational projects. How we are using by using the RAM cell memories. So first one, address decoders. Select specific flip-flops for reading or writing operations, enabling true random access to any memory locations. So the address decoders. Then synchronous design. What kind of designs we are using is common clock signals ensures perfect data integrity and precise timing control access all memory cells. So this is the synchronous design. Then educational projects. So beginners, we are using the beginner friendly RAM projects using flip-flops demonstrate fundamental scalability and more core design principles we are using in this RAM cell memory by using the D flip-flops. This is the practical implementation of D flip-flops in using in the RAM cell memories. So then innovations, what kind of innovations we are using in the RAM cell memories by using the flip-flops. So non-volatile flip-flops for future memory we are will use in the future. So that is magnetic flip-flops, OX RAM integration. So the magnetic flip-flops means NEC's breakthrough. The magnetic flip-flops retain the data without power, enabling instant on computer systems that revolutionize startup times. So this is the future aspects of the flip-flops. So next one is OX RAM integration. This is OX RAM based non-volatile flip-flops combine resistive memory with the CMOS technology. So that is the metal oxide semiconductor technology. So comprised metal oxide semiconductor technology we are using the fabrication of this kind of flip-flops or RAM cell memories in the future. So thank you for watching this video. Thank you.